Welcome students. In this video, let us look at the topic of pair of lines. Now, the combined equation of the lines a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 is the equation a1x plus b1y plus c1 into a2x plus b2y plus c2 is equal to 0. That is, if you have a line a1x plus b1y plus c1 is equal to 0, we know that this equation represents a straight line, one straight line. And if you have another straight line whose equation is a2x plus b2y plus c2 is equal to 0. Now, what is the equation of these pair of lines? So if I want to talk about both these lines at the same time, what is the combined equation of these two lines? So again, look at the definition of the equation. Equation means some condition which each and every point on the curve satisfies. So is there a condition which each and every point on this combined equation satisfies? So if this line can be written as L1 is equal to 0, where L1 is this expression, and if this line, if the second line can be written as L2 is equal to 0, where L2 is this expression, the combined equation is nothing but L1 times L2 is equal to 0. Why is this the combined equation? Because if you take any point alpha comma beta on the first line, so if you substitute alpha comma beta in this expression, it has to satisfy this equation, right? So a1 alpha plus b1 beta plus c1 will be equal to 0. If you take any point gamma delta on the second line, this gamma delta satisfies the second expression is equal to 0. Now if you take any point and substitute in this equation, if you take any point on the first line and substitute in this equation, this point makes the first expression to be 0. So 0 into anything is equal to 0. And gamma delta, if you take any point on the second line, this expression will become 0. Hence, this combined expression will be satisfied. So if you take any point either on this or on this line, they satisfy this combined equation. Hence, this is the combined equation of this pair of lines. And also, if the product of two expressions is equal to 0, I can say that this implies either a1x plus b1y plus c1 has to be 0, or a2x plus b2y plus c2 has to be equal to 0. That means if this expression, if this combined equation has to be equal to 0, the point has to satisfy either the first line or the second line. So this effectively is the combined equation of the two straight lines a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. For example, so if you have lines 2x plus 3y minus 5 is equal to 0 and x plus y minus 2 is equal to 0. These are two individual lines. Now what is the combined equation of these two lines? It is simply, so combined equation of this pair of lines is 2x plus 3y minus 5 times x plus y minus 2 is equal to 0. So if you expand this, you get a lot of terms. So let us try to expand this. So you get 2x into 2x is 2x square. 3y into y is plus 3y square. If you take the constant term, you get the constant as term. and if you multiply 2x with y, you get 2xy, 3y with x, 3xy. So 2xy plus 3xy is 5xy. So you get an x square term, you get a y square term, you get an xy term, and 2x into minus 2. 2x into minus 2 is minus 4x, minus 5 into x is minus 5x, minus 4x minus 5x is minus 9x. Next, 3y into minus 2, minus 6y minus 5y, minus 11y is equal to 0. So if you multiply two lines, two linears in x and y, you get a general quadratic in x and y. Get a general quadratic in x and y. That is, you have an x square term, you have an xy term, you have a y square term. These are quadratic terms whose degree is 2, and you have x term and a y term and a constant. So these are the different terms that you can expect in the equation of a pair of lines. So if two lines L1 is equal to 0 and L2 is equal to 0 are given, the combined equation is L1 L2 is equal to 0, and if you expand these terms, if you expand the brackets, you get an x square term, y square term, xy term, x term, y term, and a constant. You can get a maximum of 6 terms in the equation of a pair of lines. In the previous video, we have understood how to find the equation of the pair of lines if individual lines are given to you. And we have seen that the equation of a pair of lines, the general equation of a pair of lines, is a general quadratic in x and y. That is, you have an x square term, you have an xy term, you have a y square term, you have an x term, you have a y term, and you have a constant term is equal to 0. So you have some coefficients correspond to each of these terms. So let us assume that the coefficients are ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So this is the general equation of the pair of lines. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So you might be wondering why I am assuming this coefficients as 2h, 2g and 2f. So you'll understand it later. If you assume this as 2h, it leads to certain simplifications when you derive the further formula. So for now, assume that the coefficient of xy as 2h, the coefficient of x as 2g, the coefficient of y as 2f. So the general equation of the pair of lines looks like ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. For example, if you take the equation of this form, 2x square minus xy minus y square plus 9x minus 3y plus 10 is equal to 0. Now, the question that we are going to deal in this video is how to factorize this combined equation into two separate linear equations. So what is this pair of lines made of? What are the individual equations? So how do we factorize the combined equation of pair of lines? So let us see the method by which we can do that. So the method involves solving a quadratic. So you know how to solve a quadratic. So we try to convert this into a quadratic in one of the variable. So let us take x and let us convert this into a quadratic in x and solve for x. So how I do it is, you have 2x square and you can see that you have x in both these terms. So I'll take x as common from this. So plus x times 9 minus y, that is plus 9x minus xy. So 2x square, this term has been written. I'll combine these two terms. So x times 9 minus y plus minus y square minus 3y plus 10 is equal to 0. So now this equation looks like a quadratic in x whose coefficients are in terms of y. Now what is x? X is equal to the solution of quadratic minus b minus of 9 minus y plus minus root of b square minus 4ac 9 minus y whole square minus 4 into 2 8 times minus y square minus 3y plus 10 by 2a is 4. So now all these terms, both these terms are straightforward. So here you have to concentrate on this term because this term is inside the square root. So if you have to get x is equal to some nice linear in terms of y, this has to be a perfect square. I am worried now. Is this a perfect square? So let us see. I am trying to analyze the expression inside the square root. So you have 81 plus y square minus 18y plus 8y square plus 24y minus 80. That is equal to 9y square minus 18y plus 24y is plus 6y. 81 minus 80 is plus 1. So by chance, is this a perfect square? This looks so. This can be written as 3y plus 1 whole square. Right? 3y plus 1 whole square is 9y square plus 1 plus 2ab term is 6y. Luckily, this term has turned out to be a perfect square. So root of this is equal to root of this is equal to root of this is equal to 3y plus 1. So this implies x is equal to minus 9 plus y plus or minus of 3y plus 1 by 4. 4 goes here. 4x is equal to this. So if you take plus, 4x is equal to take plus, you get 4y minus 9 plus 1 is minus 8. Or 4x is equal to, so if you take a minus, y minus 3y is minus 2y, minus 9 minus 1 is minus 10. So if you cut a 4, you get x is equal to y minus 2, or if you cut a 2, 2x is equal to minus y minus 5. So these are the two lines that make this pair of lines. So let me write it nicely. X minus y plus 2 is equal to 0 and 2x plus y plus 5 is equal to 0. So these are the two lines that make up this pair of lines. So I hope you have understood how to factorize a general equation into two straight lines. So you just consider the given equation as a quadratic in one of the variable, write the quadratic formula, simplify the square root. If the square root turns out to be a perfect square, then only you can split them into two factors. Luckily that has happened here and you got both the lines. So if this is not a perfect square, you cannot find x as a linear of y. That means this will not be a pair of lines. This is a very important point. It means that not all equations of this form represent pair of lines. The equation of pair of lines will be of this form, but if you write any equation of this form, it need not represent pair of lines. We may not be able to factorize the equation into two linear equations. So now this makes us think about the question, what is the condition for an expression for a combined equation to be able to be split into two linear factors? So what is the condition which ensures that a general quadratic equation in two variables is a pair of lines? That will be the topic that we are going to deal in the next video. So let us take some examples. So first, what is the combined equation of the lines 2x plus 3y is equal to 0 and x minus y is equal to 0? As you can see, I have taken two special lines. These are lines passing through origin. So if two lines, both the lines pass through origin, if both lines pass through origin, that is the constant term in the first equation and the second equation, if both are equal to 0. So let us see how the combined equation looks like. The combined equation is nothing but 2x plus 3y times x minus y is equal to 0. That is 2x square minus 3y square. 3y into minus y is minus 3y square minus 2xy plus 3xy. That is plus xy is equal to 0. So as you can see, if there is no constant term in the equation, you have only three terms in the final equation of pair of lines: the x square term, the xy term, and the y square term. That is, you have only the quadratic terms. You won't have the linear term. You also won't have the constant term. So remember this, if both lines pass through origin, then the equation of pair of lines will be a homogeneous equation. Homogeneous simply means that every term will have the same effective power of variable. That is, the first term has a power of variable which is equal to 2. The last term has the power of variable is equal to 2. The middle term also has the effective power of variable equal to 2. That is, x has a power of 1, y has a power of 1. So the effective power of the variable is 2. So if each term has the same power of the variable, then such equations are called homogeneous equations. So if the lines pass through origin, you get a homogeneous equation. So you get a maximum of 3 terms. And if the lines do not pass through origin, you have a non-homogeneous quadratic in x and y, where you get a maximum of 6 terms. You have an x term, y term, and a constant term in addition to this. Let us go to the next example. So let us deal with a slightly changed equations. We have 2x plus 3y plus 1 is equal to 0 and x minus y is equal to 0. One line is not passing through origin, the other line is passing through origin. And observe that the linear part of both these equations is same. Now if you multiply, if you want the combined equation of this, you get 2x plus 3y plus 1 times x minus y is equal to 0. This implies 2x plus 3y times x minus y plus x minus y is equal to 0. So 2x plus 3y times x minus y has already been calculated. This implies 2x square plus xy minus 3y square plus x minus y is equal to 0. So as you can see, if one line passes through origin and the other line don't pass through origin, you have an extra x and y terms now, but the constant term is still equal to 0. If either one of the lines pass through origin, the constant term will be equal to 0. If both lines pass through origin, the x and y terms are also equal to 0. So if one line is passing through origin and the other does not, you have an xy term, and you can very clearly see that the quadratic expression is exactly same as this expression. That is, the quadratic part of the pair of lines depend only on the linear part of the lines. If the linear part of both the lines is same, then the quadratic part of the pair of lines also remains same. Next, let's go to the third example. So we have 2x plus 3y plus 1 is equal to 0 and x minus y plus 2 is equal to 0. So again, I am keeping the linear part intact. I am just adding the constants. So you have the combined equation as 2x plus 3y plus 1 times x minus y plus 2 is equal to 0. That is 2x plus 3y times x minus y, 2x plus 3y times x minus y, plus 2 times 2x plus 3y, plus 1 times x minus y, plus 2 is equal to 0. So this implies the combined form is exactly same as this. So 2x square plus xy minus 3y square. So as long as you don't change this part does not change. Plus 4x plus x is 5x. 6y minus y is 5y plus 2 is equal to 0. Now these two are generally equations which are not passing through origin. So you can see that you got all the 6 terms. You got all the 6 terms. But the quadratic part did not change in all the 3 equations. As you can see, these 3 lines are parallel to each other. These 3 lines are parallel to each other. So all these pair of lines represent a pair of parallel lines. This set is parallel to this set is parallel to this set. So as long as the pair of lines are parallel to each other, the quadratic part does not change. And the direction of the lines, as you know, the slope of the line is determined by the linear part of the line. The slope of individual lines is determined by the linear parts of the line. So if you leave the slopes intact, the quadratic part also does not change. So in the pair of lines, the quadratic part determines the direction of the lines. The quadratic part determines the direction of the lines, and the linear and constants determine the constants or the position of the lines. So I hope you have understood how to find the equation of pair of lines if the lines are given. So let us take another example to show what you should not do. Sometimes some students tend to get it wrong. So what students tend to do is, if the question is given like 2x plus 3y is equal to 1, if this is the first equation, and x minus y is equal to 2, if this is the second equation, if you're asked to find the pair of lines, if you're asked to find the equation of the pair of lines, what sometimes students tend to do is, they tend to multiply these two is equal to the multiplication of these two. It is 2x plus 3y times x minus y is equal to 1 into 2 is 2. So this is wrong, because it does not give the same answer as you do in the previous method. So the correct method will be, first write the whole expression is equal to 0 and the whole expression is equal to 0. First write the lines in the form L1 is equal to 0 and L2 is equal to 0. So 2x plus 3y minus 1 times x minus y minus 2 is equal to 0. So this will be the correct equation of the combined equation of pair of lines. This is a wrong way. Just keep in mind, you should not do this. This is a wrong way. So you cannot directly multiply as long as the right hand side is equal to 0. You can only multiply if the right hand side is equal to 0. In this video, let us look at the condition which ensures that the equation of the form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a pair of lines. So represents a pair of lines if it represents a pair of lines if the condition is determinant of AHG HBF GFC is equal to 0. So this is the statement which you need to remember. So this expression is equal to 0 represents a pair of lines if this determinant is equal to 0. And this determinant can be very easily remembered. So first AHG, just look at the terms which contains x. So x is present with A, with H, with G. So the first row contains AHG. And the second row contains the terms containing y. So y is present with H, with B, with F. So H, B, F in the second row. And the last three terms are nothing but the last three terms GFC. So if this determinant is equal to 0, then this represents a pair of lines, otherwise not a pair of lines. So how did we get this condition? So if you remember, we have also derived this condition in our chapter of quadratic equations, right? So let me redo the derivation. Again, this derivation is not required for JEE mains. So if you are interested in the derivation, then go forward, otherwise you can skip this video right now. So as we have already seen, how do we factorize this? So we factorize this by assuming that this is a quadratic in x. So ax square plus x times 2hy plus 2g plus by square plus 2fy plus c is equal to 0. So x is equal to minus 2 times hy plus g plus minus root of b square 4 times hy plus g whole square, b square minus 4a times by square plus 2fy plus c divided by 2a. So this is the value of x. So if x has to be a linear function of y, that means if this has to be able to be separated into two factors, then x has to be a linear of y. So this has to be a perfect square. This expression in y has to be a perfect square. We have discussed in the previous question also. If the expression inside the square root is a perfect square, then square root gets eliminated and you get x as a linear of y. Now this 4 and this 4 becomes 2 outside. The remaining expression is, as you can see, h square y square minus ab y square. So h square minus ab times y square, h square y square minus ab y square. Next, 2ghy minus 2afy. That is, with y you have 2gh minus 2af, that is the coefficient of y. What is the constant term? Plus g square minus ac So this is the expression inside the square root. So when will a quadratic expression be a perfect square? If the quadratic expression has to be a perfect square, then the discriminant of this expression has to be equal to 0. That means if this has to be a perfect square, I should be able to write this as some k times x minus alpha whole square. That means both the roots have to be same. If this is a perfect square, then it means it should be able to be written as x minus alpha whole square. So this has to have repeated roots. This has to have repeated roots. So that means the discriminant of this expression has to be equal to 0. And also this coefficient of y square has to be positive, because this k is nothing but h square minus ab. As we have seen, ax square plus bx plus c can be written as a times x minus alpha times x minus beta. So the condition for this to be a perfect square is, first, h square minus ab has to be positive, and the discriminant of this has to be equal to 0. That is 4 times gh minus af whole square minus 4 times g square minus ac times h square minus ab has to be equal to 0. So if you expand this, you get some condition in terms of GFC ABC. That condition is exactly same as this condition. So if you simplify this, you get some condition. If you simplify this, you get exactly the same condition. Hence, this equal to 0 makes this a pair of lines. And you have to remember, h square minus ab has to be also greater than 0 for this to be able to be factorized into 2 factors. So if this is equal to 0 and h square minus ab is positive or greater than 0. Next, if you look at the homogeneous equation, that is the small equation. So if you have ax square plus 2hxy plus by square is equal to 0. So if you have this equation, what can you say about this equation? So if you compare this equation with this equation, the difference between these two is simply that g, f and c, all these three are 0 for this equation. So if g, f, c is equal to 0 in this equation, so as you can see, this determinant's third row is completely becoming 0. So this determinant will automatically be equal to 0. So if I call this delta, for this homogeneous equation, delta is automatically equal to 0. This implies the homogeneous equation always represents a pair of lines. And if h square minus ab is greater than 0, h square minus ab is greater than 0, h square minus ab is greater than 0. As you can see, GFC is already equal to 0. So this term is 0, this term is 0, G is 0, C is 0. So all these terms, so I have written the expression that you have got inside the square root. So for this expression, for homogeneous expression, so this and this has become 0. So if h square minus ab is greater than 0, the root of this will be nicely obtained outside. Root of this will be a linear in y. So h square minus ab is greater than 0. You get two distinct lines through origin. As we have seen, the small equation comes if both the lines pass through origin. And if h square minus ab is equal to 0. So if h square minus ab is equal to 0, so this term also has become 0. So inside the square root, there is nothing left. So x is equal to minus b by a plus or minus 0. That means both lines have coincided. So coincident lines, and if h square minus ab is less than 0, so these two terms are automatically 0, you get minus of some number times y square. For example, you get minus 3y square inside the square root. Obviously this is an imaginary quantity, so you won't get real lines. So I say that they are imaginary pair of lines. That is, effectively there are no pair of lines, but that equation looks like a pair of lines. So I say that they represent imaginary pair of lines. So I hope you have understood the analysis of the general quadratic in x and y and a homogeneous quadratic in x and y. So the general quadratic in x and y represents a pair of lines if these conditions are valid. A homogeneous equation in x and y, a homogeneous quadratic, is always a pair of lines. If h square greater than ab, they represent two distinct lines. H square is equal to ab, they represent coincident lines, and h square minus ab less than 0, they represent imaginary pair of lines. Remember, imaginary pair of lines means that there are no pair of lines, because inside the square root you get something like minus 3y square or something. So you get an I with y. That is not a pair of lines. That is not a line. So now let us go forward. In this video, let us look at the analysis of the homogeneous equation ax square plus 2hxy plus by square is equal to 0. This is the most important topic of your pair of lines. So first, we know that this represents a pair of lines which pass through origin, right? Because the linear terms and constant terms are not there. So this represents the equation of a pair of lines, both of which are passing through origin. So pair of lines, both passing through origin. So let us say that this equation is made up of lines y is equal to m1x and y is equal to m2x. That means let us say that the slopes of the lines making this equation are one m1 and the other m2. Now, what is the relation between m1, m2 and the coefficients a, 2h, b? So that's what we are going to analyze. So to do that, there are two methods. The first is, so let us try to get the equation of the pair of lines y is equal to m1x and y is equal to m2x and compare it with the given equation. So if this represents the pair of lines which are y is equal to m1x and m2x, so y minus m1x times y minus m2x is equal to 0 has to represent the same equation. This implies y square minus m1xy minus m2xy, that is y minus m1 plus m2 times xy plus m1 m2 x square is equal to 0. So this is the equation of the pair of lines y equal to m1x and y equal to m2x. Again, I am saying that this also represents the pair of lines y equal to m1x and y equal to m2x. So these two lines have to be exactly same. That means the coefficients of the corresponding powers have to be proportional. So this implies what is the y square coefficient here? 1 divided by what is the y square coefficient here? B is equal to what is the xy coefficient here? Minus of m1 plus m2. What is the xy coefficient here? 2h is equal to what is the x square coefficient here? m1 m2 divided by a. So this has to be valid. This implies m1 plus m2 is equal to equate these two, m1 plus m2 is equal to minus 2h by b and m1 m2 is equal to a by b. So these are the most important equations in this chapter. So if you take a homogeneous equation, if this equation is made up of two lines whose slopes are m1 and m2, and the sum of the slopes is minus 2h by b, and the product of the slopes is a by b. So these equations look very similar to what you had in quadratic equations. So minus b by a, c by a. Here, just remember that, keep in mind that you have b in the denominator, not a. So minus 2h by b, it is minus of xy coefficient by y square coefficient, and the product of the roots is a by b. So these are the equations which you remember. So this same topic, same equations can also be derived by converting this equation into a quadratic in M. That is, instead of assuming y equal to m1x and m2x as the roots, let us say that y is equal to mx satisfies this equation. This y is equal to some mx satisfies this equation. So that means you get ax square plus, in the place of y, if you put mx, so you get 2hmx square, and in the place of y you get mx, so this becomes m square x square, so plus bm square x square is equal to 0. So this x square gets cancelled, so you get bm square plus 2hm plus a is equal to 0. So this is the quadratic which m satisfies. If the roots of this equation are m1 and m2, what is the sum of the roots? m1 plus m2 is equal to minus of m coefficient by m square coefficient, and m1 m2 is equal to constant by m square coefficient. So m1 plus m2 is minus 2h by b, m1 m2 is a by b. So let us see how we can apply these equations while solving problems. In this question, we are asked to find the condition that the lines making up this equation has slopes of one line square of the other. So ax square plus 2hxy plus by square is equal to 0. Find the condition so that the slope of one line making this pair is square of the other slope. So let us assume that the slopes are, so let the slopes be alpha comma alpha square. It's given that one slope is square of the other. So if one slope is alpha, the other slope has to be alpha square. And what do we know about alpha and alpha square? We know two things about this. First is alpha plus alpha square is equal to minus 2h by b. The second is alpha into alpha square is equal to a by b. So from the second equation, you get alpha cube is equal to a by b. This implies alpha is equal to a by b whole power 1 by 3. So if one root is square of the other, that root has to be equal to a by b whole power 1 by 3. Now alpha is equal to a by b whole power 1 by 3. Substitute here. So this implies a by b whole power 1 by 3 times 1 plus a power 1 by 3. If you take alpha, alpha times 1 plus alpha, that is a by b whole power 1 by 3 times 1 plus a power 1 by 3 is equal to minus 2h by b. So this will be the condition which ensures that one root of one slope is square of the other slope. In this question, you're given that ax square plus by square plus cx plus cy is equal to 0 represent a pair of lines. Then what should be the condition? So this is, if you compare this equation with the general equation, so you can very clearly see that the xy term is missing and the constant term is missing. So the condition for this to be a pair of lines is nothing but determinant of x square coefficient is a, xy coefficient is 0, x coefficient is 2g, but I need a g here, so you have c by 2, right? So if you compare this coefficients with the original equation, a is equal to a, b is equal to b, h is equal to 0, 2g is equal to c, 2f is equal to c, and c is equal to 0. So a, h, g, h, b, f, g, f, c has to be equal to 0. So this is the required condition. So you just need to expand the determinant. So a times 0 minus c square by 4 plus 0 times something is 0 plus c by 2 times 0 minus bc by 2 is equal to 0. So this 4 and this 4 gets cancelled. So minus minus gets cancelled. So ac square plus bc square has to be equal to 0. This implies c square times a plus b is equal to 0. So if you assume c is not equal to 0, then a plus b has to be equal to 0. So if a plus b is equal to 0, this equation represents a pair of lines. So option A is the right answer. In this question, you're given that 6x square plus 2hxy plus 12y square plus 4x minus 2y plus 1 is equal to 0 represent a pair of lines. If that is so, what is the value of h? So we know the condition for general non-homogeneous quadratic in x and y to be a pair of lines. So the condition is nothing but determinant of 6 h 2 h 12 minus 1 2 minus 1 1 has to be equal to 0. So this implies 6 times 12 minus 1 is 11 minus h times h plus 1, sorry, h plus 2 plus 2 times minus h minus 24 is equal to 0. This implies 66 minus h square minus 2h minus 2h minus 48 is equal to 0. So if you send all the terms onto that side, you get h square plus 4h 48 minus 66 plus 48 minus 66. So you get 66 minus 48 is 58, 68, 18 is equal to 0. So h square plus 4h minus 18 is equal to 0. So h has to be equal to, obviously you can see that this cannot be nicely factorized. And what is the value of h? Minus 4 plus minus root of b square minus 4ac, that is 4 times 18, 72 by 2. That is equal to minus 4 plus or minus root 88 by 2. That is equal to minus 4 plus or minus. So this is 2 root 22. So sorry, minus 2. So if you cancel it 2, minus 2 plus or minus root 22. So this is the value of, possible value of h. but the other condition which needs to be valid is h square greater than AB for the lines to be real. So h square has to be greater than A into B is 12 into 6, 72. So if you see the approximate values of h, so h is approximately equal to root 22 is something like 4.7. So minus 2 plus 4.7 is approximately 2.7. Minus 2 minus 4.7 is minus 6.7. And in both cases, you can see that the square of these two numbers are less than 72. So for neither of these values, h square is greater than AB. So what is the meaning of this? No value of h exists. No value of h exists for this equation to be a real pair of lines. In this question, you're asked to factorize 6x square minus 5xy plus y square is equal to 0 into two lines. This is a homogeneous equation, so this is very easy to factorize. You can factorize it by assuming this as a quadratic. So first what I say is, let y is equal to mx satisfy this equation. Let y is equal to mx satisfy this equation. This implies y by x is equal to m. Now let me divide the whole equation with x square. So you get 6 minus 5y by x plus y by x whole square is equal to 0. So by my assumption, y by x is assumed as m. So m square minus 5m plus 6 is equal to 0. This can be very easily factorized into m minus 2 times m minus 3 is equal to 0. This implies m is equal to 2 or 3. M is equal to either 2 or 3. So this implies the lines are y is equal to 3x or y is equal to 2x. So these are the equations of lines which make up this equation. In this video, let us look at how to find the angle between the pair of lines represented by the equation ax square plus 2hxy plus by square is equal to 0. So now you have this pair of lines. So we have already seen that if this pair of lines is made up of two lines, y is equal to m1x and y is equal to m2x, then m1 plus m2 is equal to minus 2h by b and m1 m2 will be equal to a by b. Now using these two relations, can you find the angle between these two lines? So as you can clearly see, one line has the equation y equal to m1x. That means the slope of the first line is m1 and the slope of the second line is m2. So what is the angle between two lines whose slope is m1 and m2? We have seen this in the topic of straight lines. So tan theta is equal to m1 minus m2 by 1 plus m1 m2, right? So if you take mod here, you get the acute angle between the two lines, because if you take two lines, you have an acute angle between them and an obtuse angle between them. So if you want the acute angle, you just need to take mod of this. So that is equal to, so what is m1 minus m2? You know what m1 m2 is. You know what m1 plus m2 is. So from these two, can you find what m1 minus m2 is? So m1 minus m2 whole square is equal to m1 plus m2 whole square 4h square by b square minus m1 minus m2 whole square is equal to m1 plus m2 whole square minus 4m1 m2 minus 4a by b. That is equal to 4 times h square minus ab by b square. So this is m1 minus m2 whole square. So what is mod of m1 minus m2? It is mod of 2 times root of h square minus ab divided by b by 1 plus m1 m2 is a by b. So if you take the LCM, you get a plus b by b. So b and b will get cancelled. So you get mod of 2 root h square minus ab by a plus b. So this is the formula for tan theta. So tan theta is equal to 2 root h square minus ab by a plus b. So if you take a pair of lines of this form, then the tan of angle between the lines is mod of 2 root h square minus ab by a plus b. So if tan theta is equal to this expression, what is the condition that the two lines making this pair of lines are perpendicular to each other? So condition for perpendicularity is, so if the angle between the two lines is 90 degrees, then tan 90 degrees, which is undefined. So what is the condition for theta to be 90 degrees? So if theta has to be 90 degrees, this has to be undefined. That means the denominator has to be equal to 0. So a plus b has to be equal to 0. So if the sum of the x square coefficient and the y square coefficient is equal to 0, then the lines making this pair of lines are perpendicular to each other. And condition for coincident lines. Condition for coincident lines. We know that both the lines pass through origin, and if the angle between the lines is equal to 0, both lines are passing through origin, and if the angle between both lines become equal to 0 degrees, then obviously both the lines will be coincident lines, right? So what is the condition that both the lines are coincident? The angle has to be equal to 0. So h square minus ab has to be equal to 0, or h square is equal to ab. So if h square is equal to ab, then the lines are coincident. If a plus b is equal to 0, then the lines are perpendicular to each other. So these are the two conditions which you need to keep in mind. One is the formula for angle between the lines. Tan theta is equal to 2 root h square minus ab by a plus b. And the condition for perpendicularity, the coefficient of x square plus coefficient of y square is equal to 0. Condition for coincident lines, h square is equal to ab. In this video, let us look at how to find the angle bisectors of the lines represented by ax square plus 2hxy plus by square is equal to 0. So let us say that these two lines represent the pair of lines ax square plus 2hxy plus by square. So there will be two angle bisectors correspond to these pair of lines. You have one bisector like this and the other bisector like this. So the combined equation of these two pair of lines is given by x square minus y square by a minus b is equal to xy by h. So you need to remember this equation. X square minus y square by a minus b is equal to xy by h. The derivation of this is quite involved. So if you are interested in derivation, go through the process. Let me just tell you the steps that are involved. And if you just are interested in remembering this equation, that will be enough. So x square minus y square by a minus b is equal to xy by h. How do we get this equation? So first we assume that this pair of lines is made up of y is equal to m1x and y is equal to m2x. And m1 plus m2 is equal to minus 2h by b, m1 m2 is equal to a by b. These are two equations which we know. So what is the equation of the bisector of the lines y minus m1x is equal to 0, y minus m2x is equal to 0? We have already discussed how to find the bisectors, angle bisectors in the topic of straight lines. So y minus m1x by root of 1 plus m1 square is equal to plus or minus of the second line by root of x coefficient square plus y coefficient square. So if you take plus, you get one equation. If you take minus, you get the other equation. So this is one angle bisector, this is the other angle bisector. Now what is the combined equation? The product of these two is equal to 0. So as you can see, this is of the form something plus something into something minus something. So the equation is something square minus something square is equal to 0. So y minus m1x whole square by 1 plus m1 square is equal to y minus m2x whole square by 1 plus m2 square. So this is the combined equation. Now this equation is in terms of m1 and m2. Now let us simplify this and use the relations m1 plus m2 and m1 m2. So you just need to cross multiply. So you have y square, just separate the y square terms, x square terms and xy terms. So you know how to do the LCMs and just separate the terms. And once you get this expression, you can see that m1 minus m2 is common in all the three equations, all the three terms. So if you cancel that m1 minus m2, the remaining is x square minus y square times m1 plus m2 is remaining. So m1 plus m2 is minus 2h by b is equal to 2xy times m1 minus m2 has already been cancelled out. 1 minus m1 m2 is a by b. If you just simplify this expression by taking LCM, you get x square minus y square by a minus b is equal to xy by h. So you need to carefully remember this equation. And you need to observe here that the coefficient of x square plus the coefficient of y square is always equal to 0 for angle bisectors. That means the angle bisectors are always perpendicular to each other. The angle bisectors are always perpendicular to each other. So let us look at a very simple question to see how we can apply this formula. In this question, you are asked to find the angle between the pair of lines represented by this equation. So as you can see, this is a non-homogeneous equation. So we have already derived how to find the angle between the pair of lines for a homogeneous equation. So how do we find? So we know that tan theta is equal to 2 root h square minus ab by a plus b. This is the formula for angle between the lines in homogeneous equation. Ax square plus 2hxy plus by square is equal to 0. So as we know, the angle between the pair of lines, depend only on the slopes of the lines. And in the non-homogeneous equation, we have seen that the slopes of the line determine the quadratic part of the equation and the constants determine the non-homogeneous part of the equation, right? So the angle between the lines, even in non-homogeneous equation, is determined by the quadratic part. So we can use the same formula for angle between the lines even for non-homogeneous equation. So this implies tan theta is equal to modulus of 2 times root of h square minus ab. H is 5 by 2, so 25 by 4 minus of a into b is 4 by a plus b is 1 plus 4 is 5. That is equal to 3 by 5. So theta is nothing but tan inverse of 3 by 5. So this will be the angle between the pair of lines. In this question, you're given a pair of lines 2x square plus 4xy plus by square is equal to 0. Now you are asked to find the value of unknown b if the lines are perpendicular, that's the first case, and if the lines are coincident. So we have already derived the conditions correspond to these two cases. So if the lines are perpendicular, then the coefficient of x square plus coefficient of y square has to be equal to 0. This implies b is equal to minus 2. And if the lines are to be coincident, then h square has to be equal to ab. This implies h is 2. So 2 square is equal to 2 into b. This implies b has to be equal to plus 2. So if b is equal to minus 2, then the lines are perpendicular to each other. If b is equal to plus 2, then the lines are coincident. In this question, you are given the equation of a homogeneous pair of lines. 3x square plus xy minus 2y square is equal to 0. And you are asked to find the pair of angle bisectors. So I'll directly use the formula x square minus y square by a minus b is equal to xy by h. So this is the formula for pair of angle bisectors. So we just need to substitute the numbers. So x square minus y square by a minus b is 3 minus of minus 2 is 5 is equal to xy by h is 1 by 2, because 2h is the coefficient of xy. 2h is equal to 1, so h is equal to 1 by 2. This implies x square minus y square is equal to 10xy. This implies x square minus 10xy minus y square has to be equal to 0. So in this video, let us look at how to find the point of intersection of a generalized non-homogeneous pair of lines. So to find the point of intersection, the process is very simple. We assume this expression as some expression in x comma y. So this can be written as some expression of x comma y is equal to 0, or some function of x comma y is equal to 0. So the point of intersection can be obtained by solving dou phi by dou x is equal to 0 and dou phi by dou y is equal to 0. So the point of intersection of these two equations is nothing but the point of intersection of the straight lines. So if you differentiate this partially with respect to x, you get 2ax plus 2hy plus 2g is equal to 0. That is, ax plus hy plus g is equal to 0. Next, dou phi by dou y, if you partially differentiate this with respect to y, so you get 2hx plus 2by plus 2f is equal to 0. This implies hx plus by plus f is equal to 0. So if you solve these two equations, the point of intersection of these two linear equations is nothing but the point of intersection of these straight lines. So you can solve this by using cross multiplication method. So x minus y 1. So x divided by hf minus bg, hf minus bg is equal to minus y divided by af minus gh is equal to 1 divided by ab minus h square. So this implies the point of intersection x comma y is given by x is equal to hf minus bg by ab minus h square, or bg minus hf by h square minus ab comma. The next point will be, if you take the minus and give it to this denominator, the denominator becomes h square minus ab. So af minus gh by h square minus ab. So this is the expression for the point of intersection of the lines given by this equation. So you don't need to remember this explicitly, but you need to remember the process by which we can find the point of intersection. That is, by solving the partial differentials of this equation with respect to x and y. For example, if you are asked to find the point of intersection of this pair of lines, 2x square minus xy minus y square plus 9x minus 3y plus 10 is equal to 0. So in the question, it is given that this is a pair of lines and you are asked to find the point of intersection. So the process is very simple. First, differentiate this expression partially with respect to x. That is, take y as a constant. So 2x square differentiation becomes 4x, minus xy's differentiation becomes minus y. This differentiation becomes 0, plus 9 is equal to 0. And let us partially differentiate this with respect to y now. So you get minus x minus 2y minus 3 is equal to 0. Now you need to solve these two to get the point of intersection. So I'll multiply this with 4. So if you add these two, 4x minus 4x gets cancelled. Minus y minus 8y is minus 9y. 9 minus 12 is minus 3 is equal to 0. So 9y is equal to minus 3. So y is equal to minus 1 by 3. Y is equal to minus 1 by 3. And once you put y is equal to minus 1 by 3 here, so 4x plus 1 by 3 plus 9 is equal to 0. So 12x plus 28 is equal to 0. This implies x is equal to minus of 14 by 6 or minus 7 by 3. So the point of intersection is nothing but minus 7 by 3 comma minus 1 by 3. So this is the point of intersection of these two lines. But the important thing that you need to understand is, by solving these two line equations, you are getting the point of intersection. But don't get confused that these represent the lines that make this equation. No. If you factorize this, you get some other lines. These are not the lines which make up this equation. Please keep this in mind. If you are asked to find the individual equations which make up this line, you cannot do partial differentiation and get the answers. This method is only useful in finding the point of intersection. There is no relation with these lines with the lines that make this pair of lines. So do the partial differentiation, solve them, you get the point of intersection. That's it. So partial differentiation will not be useful in factorization of this pair of lines. In this question, you're asked to prove that this equation represents a pair of lines, and once you are sure that this represents a pair of lines, you're asked to find the point of intersection. So again, a very straightforward question. So how do we check whether this represents a pair of lines? We have the condition that delta has to be equal to 0. So delta is equal to determinant of 2, 5 by 2, 3. 5 by 2, 3, 7 by 2, 3, 7 by 2, 4. So this is the determinant. If this determinant is equal to 0 and h square greater than AB, what is h? H is 5 by 2 whole square minus AB is 6 greater than 0. So if these two conditions are valid, then this equation represents a pair of lines. So here you have 25 by 4 minus 6. So is greater than 0 is true, because 25 by 4 minus 6 is 1 by 4. Is greater than 0 is true. Now let us check whether this is equal to 0 is true or not. So 2 times 12 minus 49 by 4 minus 5 by 2 times 10 minus 21 by 2 plus 3 times 35 by 4 minus 9. That is equal to 2 times 48 minus 49 is minus 1 by 4 minus 5 by 2 times again minus 1 by 2 plus 3 times minus 1 by 4. So that is equal to 1 by 2. So minus 1 by 2 plus 5 by 4 minus 3 by 4. So you can very clearly see that this is equal to 0. Hence, this represents a pair of lines. Now you are asked to find the point of intersection. So let us use our process. So first do the partial differentiation of this with respect to x. So you get 4x plus 5y plus 6 is equal to 0. And next do the partial differentiation with respect to y. So 5x plus 6y plus 7 is equal to 0. So you have to solve this. So you have, let me solve this using cross multiplication method. X divided by is equal to minus y divided by is equal to 1 divided by. So x by 35 minus 36 is minus 1 is equal to minus y by 28 minus 30. 28 minus 30 is minus 2 is equal to 1 by 24 minus 25 is minus 1. So on comparison, x is equal to 1, y is equal to minus 2. That means the point of intersection is 1 comma minus 2. Again, remember that whatever linear equations you got, these are not the individual lines that make up this equation. If you are asked to find the individual lines that make up this equation, you have to do that by factorization method. That is, we assume this equation as a quadratic in x and used quadratic formula, right, in the beginning. So that's the method that you need to follow if you have to factorize this line. If you just want the point of intersection, you can use this method. In this video, let us look at the various conditions for parallelity and perpendicularity of lines represented by this general equation. Suppose that you have a general equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Now this equation represents two parallel lines if and only if h square is equal to ab and af square is equal to bg square. H square is equal to ab and af square is equal to bg square. If these two conditions are valid, then this pair of lines represent two parallel lines, and if this represent two parallel lines, then this condition is valid. So these conditions are valid in both directions. If the lines are parallel, then this will be valid. If this is valid, then the lines will be parallel. This equation can also be written as a by h is equal to h by b is equal to g by f. So if you take these equations and simplify, you get exactly the same equations as this. So you can see by cross multiplication you get h square is equal to ab, and if you further simplify you get af square is equal to bg square also. And these lines represent perpendicular lines if the sum of x square coefficient and y square coefficient is equal to 0. The sum of x square coefficient plus sum of y square coefficient is equal to 0 implies these represent a pair of perpendicular lines. Apart from this, delta should also be equal to 0 obviously. Next, these represent a pair of coincident lines if g square is equal to ac, f square is equal to bc and h square is equal to ab. If these three conditions are valid, then both lines will become coincident. And if these lines represent two parallel lines, if the lines represented by this equation are parallel, the distance between the parallel lines is directly given by 2 root g square minus ac by a times a plus b, or 2 root f square minus bc by b times a plus b. So these are the formulae to directly find the distance between the two parallel lines. So these are certain results which you need to remember. So let us see why these conditions are valid in the next video, but the derivations again are not required. If you are interested, go to derivations. If you are not interested, you can just remember these conditions and skip the derivations. So let us look at the first condition of parallelity. So let us say that ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represent two parallel lines. That means both the lines making this equation have same slopes, right? So let the slopes of the lines be m comma m. Now we know that if m1 and m2 are the slopes which make up this pair, m1 plus m2 is equal to minus 2h by b, m1 m2 is equal to a by b. Now if the two slopes are equal, let us assume both to be m's. So 2m is equal to minus 2h by b, so m is equal to minus 2h minus h by b, and m1 into m2 becomes m into m square is equal to a by b, and substitute m from this equation in this equation. So m square is h square by b square is equal to a by b, so h square has to be equal to ab. If the both slopes of lines are equal, then h square has to be equal to ab. That's the first part. And once h square is equal to ab, if the lines are real, they have to be parallel. Next, if the lines have to be real, then delta should also be equal to 0. So apart from this, if delta is also equal to 0, then they represent parallel lines. So if delta is equal to 0, so if you expand this determinant, you get this condition: a times bc minus f square minus h times hc minus gf plus g times hf minus bg. So if you expand this, you get this. H square is already equal to ab, so abc and abc will get cancelled out. Next, if you take this, so this becomes AF square plus BG square minus 2FG H is root AB is equal to 0. So if you multiply the whole equation with a minus, so this is equal to 0. So if you observe this, this is nothing but root A times F minus root B times G whole square is equal to 0. So what is this whole square? AF square plus BG square minus 2FG root A root B. So something whole square is equal to 0 implies something has to be 0. So F root A has to be equal to G root B. By squaring, you get AF square is equal to BG square. So if AF square is equal to BG square, then this represents a pair of lines, real pair of lines. And if H square is equal to AB, they represent two lines with same slope. Hence they become parallel. So these two conditions ensure that the lines are parallel to each other. Next, if these lines represent a pair of perpendicular lines, then simply the condition is M1, M2 has to be equal to minus 1. But M1, M2 is equal to A by B has to be equal to minus 1. This implies A plus B is equal to 0. So if A plus B is equal to 0, this equation represents a pair of perpendicular lines. And apart from this, if delta is also equal to 0, they represent a real pair of lines, and A plus B is equal to 0 ensures that the lines are perpendicular to each other. So these are the two conditions which need to be valid for the lines of this equation to be perpendicular to each other. Next, if these pair of lines have to represent the lines which are coincident, that means the same equations, exact same equations, what has to be satisfied? What is the condition that needs to be satisfied? So for this, we go to the derivation regarding factorization of this equation. So we have already done this initially. So if you consider this as a quadratic in x, x will be equal to minus of this plus minus root of this by 2a. Now, if this equation has to represent a pair of coincident lines, then the condition is simply that all these expressions have to be equal to 0. So I should not get any plus minus some number. So if you have plus minus some expression, with plus you get a different expression, with minus you get another expression, which means two different lines. So if you want coincident lines, that means this whole term has to be exactly equal to 0. That means h square minus ab has to be equal to 0 and gh has to be equal to af and g square has to be equal to ac. So if h square minus ab is equal to 0, gh minus af has to be equal to 0, g square minus ac has to be equal to 0. So h square is equal to ab, g square is equal to ac, and if you simplify this condition, if you square it on both sides, you get g square h square is equal to a square f square, and h square is equal to ab. So g square ab is equal to a square f square. So 1a will get cancelled. So this implies af square is equal to g square b and g square is equal to ac. So af square is equal to acb. A is getting cancelled. So f square is turning out to be equal to bc. So if h square is equal to ab, if h square is equal to ab, g square is equal to ac and f square is equal to bc, then the lines are coincident. They are not just parallel, they are exactly the same equations. They are coincident lines. Next, let us look at the derivation for the distance between parallel lines. So suppose that this equation represents two parallel lines, and we have seen that the conditions that need to be satisfied for two lines to be parallel is h square is equal to ab and af square is equal to bg square. So these are the two conditions which need to be satisfied. Now, if they represent a pair of parallel lines, let us assume that lines be y equal to mx plus c1 and y is equal to mx plus c2. So let us say that these are the two lines which make up this equation. Now, what is the pair of lines corresponding to these two equations? So y minus mx minus c1, y minus mx minus c2 is equal to 0. So this product represents the pair of lines. So if you multiply this, you get this expression: y square minus 2mxy plus m square x square minus something into x plus something into y plus something is equal to 0. Now this equation and this equation have to be same because both are made up of these lines. So the ratio of coefficients have to be same. So y square coefficient 1 by y square coefficient is b. xy coefficient is minus 2m, xy coefficient is 2h. So in this way, all the ratios of coefficients have to be same. So from this, you can get c1 plus c2 by equating this and this. c1 plus c2 is minus 2f by b and c1 c2 is c by b. And what is the distance between the parallel lines? Difference between the constants by root of a square plus b square. This, if I can find this value, this will be the perpendicular distance between the pair of lines. So from these equations, I know c1 plus c2 and c1 c2. So from these two, can I find c1 minus c2? Yes. c1 minus c2 is nothing but root of c1 plus c2 whole square minus 4c1 c2. So you got this equation that is equal to 2 times root of f square minus bc by b. So c1 minus c2 is this. So once you substitute c1 minus c2 and m square in this equation, you get the formula for distance between the parallel lines. So this is equal to 2 root f square minus bc divided by b into root of 1 plus m square, that is root of 1 plus, what is m square? M square by a is equal to 1 by b. So m square is equal to a by b. So if you simplify this, you get 2 root f square minus bc. By the denominator also you get b times a plus b. So this is the formula for the distance between the pair of parallel lines. 2 root f square minus bc by b times a plus b. And we already know that f square is equal to bg square by a. bg square by a. So if you substitute f square is equal to bg square by a and do some basic simplifications, you get that is also equal to root g square minus ac by a times a plus b. So you just need to substitute f square is equal to b by a times g square and do 2 to 3 steps. You'll end up with this expression. So try to remember these expressions if you want to do sums fast. In this video, let us look at how to find the angle bisectors of the general second degree non-homogeneous equation. So we know that this equation represents a pair of lines not passing through origin. So how do we find the angle bisectors? So first what we do is, okay, let us say that this is this pair of lines. Now let us transform this, let us shift this pair of lines parallelly so that this point of intersection goes to origin. That is, you are transforming the equations parallelly. So what is the equation of these two pair of lines? So this will be nothing but, because the slopes are not changing, because we have parallelly transformed the lines, the slopes are not changing. So these pair of lines will have the equation ax square plus 2hxy plus by square is equal to 0. Only the non-homogeneous part disappears, the homogeneous part remains same, because the homogeneous part determines the slope of the lines. Now we know the equation of the angle bisectors of this equation. X square minus y square by a minus b is equal to xy by h. So this equation represents the angle bisectors of these lines. So let us say that they represent this line and this line. Now can you see that the angle bisectors of these pair of lines will also be exactly in the same direction as this? They'll be exactly in the same direction as this, just that this origin will be shifted to the point of intersection h comma k. So if we just, without changing the direction, if we just take these lines and put it here so that the origin becomes this point h comma k, those lines will be the angle bisectors. So you're talking about curve shifting to the point h comma k without changing the direction. So I'm not changing the direction of the lines, I'm just taking this parallelly and putting it here. So what is the transformation which ensures that the curve gets transformed, the curve gets translated from origin to the point h comma k? So we just need to put x minus h in the place of x, y minus k in the place of y. The curve gets shifted to h comma k. So the corresponding equation is nothing but x minus h whole square minus y minus k whole square by a minus b is equal to x minus h times y minus k by h, where we have already have a h here. So let us take these points as x1, let us take these points as x1, y1, because h is already used in the denominator. So the equation is nothing but x minus x1 whole square minus y minus y1 whole square by a minus b is equal to x minus x1 times y minus y1 by h. So where x1, y1 is the point of intersection of these lines. So if you want the pair of angle bisectors, first you need to find the point of intersection of these lines by the partial differentiation method. So once you have this, you write this equation, and in the place of x you write x minus x1, in the place of y you write y minus y1. You get the equation for angle bisectors of these pair of lines. In this question, you're given a pair of lines and you're asked to find the distance between these parallel lines. That means indirectly you're given that the lines which are represented by this pair are parallel to each other, and you're asked to find the distance between the parallel lines. So first let us check whether the lines are actually parallel. If the lines are parallel, what are the conditions that needs to be satisfied? H square is equal to AB and AF square is equal to BG square. So if these two conditions are valid, then they represent parallel lines. So let us check whether these two conditions are valid or not. H square, H is 3, H square is 9 is equal to 1 into 9. Yes, H square is equal to AB is satisfied. Next, AF square, A is 1 times F. F is 9 by 2. So 9 by 2 minus 9 by 2 whole square is equal to BG square. B is 9 into G is 3 by 2 whole square. So 81 by 4 is equal to 81 by 4. Yes. So H square is equal to AB and AF square is equal to BG square. So both the conditions are valid. Now what is the distance between the parallel lines? 2 root G square minus AC by A times A plus B. So you can use any of the formula. You can use either F square minus BC by B into A plus B or this. You get the same answer. That is equal to 2 times root of G square. G is 3 by 2. So G square is 9 by 4 minus AC. 1 times minus 4 is plus 4 divided by A is 1 times A plus B is 10. That is equal to 2 into root of 9 plus 16 is 25 by 4 times 10. That is equal to root 4 and 2 gets cancelled. So 5 5s are 5 2s are. So the answer is root of 5 by 2 units. In this video, let us look at a process called the process of homogenization. So the statement corresponding to this process is that the equation of the pair of lines joining the origin with the points of intersection of ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 and lx plus my plus n is equal to 0 is ax square plus 2hxy plus by square plus 2gx times lx plus my by minus n plus 2fy times lx plus my by minus n plus c times lx plus my by minus n whole square is equal to 0. So what is the meaning of this? Suppose that you have a general equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. We have already seen that this equation need not always represent a pair of lines. This equation might represent a pair of lines if delta is equal to 0. Otherwise, it might represent some other curve. Suppose that this is some curve which looks like this, any curve, and you have this curve and a line lx plus my plus n is equal to 0. Let us say that this line cuts this curve at 2 points A and B. Now, I want the pair of lines joining the origin with the points of intersection. That is, origin to A is one line, origin to B is another line. So I want the equation of these two pair of lines. So this equation of the pair of lines can be obtained by homogenizing this equation with respect to this equation. What is meant by homogenization? It means simply that you have to make this non-homogeneous equation into a homogeneous equation. So why is this equation called a non-homogeneous equation? We have already dealt with this initially, because all the terms in this equation does not have the same degree. The first three terms are quadratic terms, the next two terms are linear terms, c is a constant term. A homogeneous equation is an equation where all terms have the same power. And we have already seen that a homogeneous second degree equation always represent a pair of lines passing through origin. Now, how do we homogenize this equation with this equation? So, the straight line, you can see that lx plus my is equal to minus n. So, lx plus my by minus n is equal to 1. So I can multiply 2gx with lx plus my by minus n, and 2fy is nothing but 2fy into 1. So 2fy times 1 can be replaced with lx plus my by minus n plus c times lx plus my by minus n whole square. So to the linear term I am multiplying a linear term. To a linear term I am multiplying a linear term. To the constant term I am multiplying a quadratic term, such that all the terms will become quadratic terms. So as you multiply these two, 2gx into lx becomes x square term, this will become xy term, xy term, y square term. So if you multiply these two, you get x square, y square and xy term. So once you homogenize this equation with respect to this line, you get the equation of these pair of lines. So let us see how this is working first, and then let us see why this is working. In this question, you're asked to find the angle between the pair of lines joining the origin with the point of intersection of these two curves. That is, you have a general quadratic. This might be some curve which looks like this. And you have the line y is equal to 3x plus 2, which might look like this. And these are the 2 points of intersection. Now you're asked to find the angle between the pair of lines joining origin with these points of intersection. You're asked to find this angle theta. So how can we do this? First, we'll try to find the equation of this pair of lines, and once you get the equation, we have the formula for angle between the lines. So how do we get this pair of lines? So this pair of lines can be obtained by homogenizing the second degree equation with the first degree equation. So equation of pair of lines is x square plus 2xy plus 3y square. The quadratic terms does not change, plus 4x times, this is a linear term, so we have to make this into a quadratic term. So 4x times, so carefully observe this equation, y is equal to 3x plus 2. This implies y minus 3x is equal to 2. This implies y minus 3x by 2 is equal to 1. Y minus 3x by 2 is equal to 1. So 4x can be written as 4x times 1, or y minus 3x by 2 plus 8y times again y minus 3x by 2 is equal to 11 times y minus 3x by 2 whole square. For linear terms, we multiply a linear, with the constant we multiply a quadratic. This implies, so what is the effective x square term that you have? X square here, so this 2, let's cancel 2 times, 4 times, so x square minus 6x square, so you have minus 5x square, 3y square plus 4y square plus 7y square, 2xy plus 2xy, 4xy minus 12xy. This minus 8xy is equal to 11 by 4 times y square plus 9x square minus 6xy. So this implies this 4 gets multiplied here. So you have minus 20x square. If this goes on to that side, 9x square plus 20x square is 29x square. You have 28y square, have 11y square here. So 11y square minus 28y square is minus 17y square. minus 32xy, you have a minus 66xy. So minus 66xy plus 32xy. So 66 minus 32 is 34xy is equal to 0. So you have 29x square minus 17y square minus 34xy is equal to 0. So this implies on cross multiplication. So you have minus 20x square, 99x square here. So 99 plus 20. 99 plus 20. 119x square. So you have a 28y square and 11y square. 11y square minus 28y square. It is minus 28 minus 11 is 17y square, and minus 32xy, you have a minus 66xy here. So minus 66 plus 32 is 34xy is equal to 0. So if you cancel a 17 here, so 17 sevens are 119. So you get 7x square minus 2xy minus y square is equal to 0. So this will be the equation of this pair of lines. So what is the angle between the pair of lines? Tan theta is equal to 2 root h square minus AB. H is 1. So 1 square is 1 minus AB is plus 7 by A plus B. 7 minus 1 is 6. That is 2 times root 8 is 2 root 2 by 6. This implies theta is equal to tan inverse of 2 root 2 by 3. Theta is equal to tan inverse of 2 root 2 by 3. So this will be the angle between these pair of lines. In this video, let us look at why this process of homogenization works. What is the logic of this process? So let us say that you have a general curve ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. You have a line lx plus my plus n is equal to 0. So if you take the first curve, it might represent a pair of lines or might not represent a pair of lines, depending on what the value of delta is. Suppose that you have some curve which looks like this. It can be any curve. Suppose that this curve looks like this. And you have a line lx plus my plus n is equal to 0. Now these are intersecting at 2 points A and B. Obviously, if you take the point of intersection of a quadratic with linear, you get 2 points of intersection. Now, you're asked to find the pair of lines joining the origin with these 2 points. You have to find the pair of lines OA and OB. So first, let us homogenize this equation with this equation. Let us write the equation and see what that equation represents. So let us consider this equation ax square plus 2hxy plus by square plus 2gx times lx plus my by minus n plus 2fy times lx plus my by minus n plus c times lx plus my by minus n whole square is equal to 0. So let us first consider this equation. Let us see what this equation represents. So the first thing that you need to observe is this is a homogeneous equation in xy of degree 2. Because if you see every term, this is a quadratic term, this is a quadratic term, this is a quadratic term. So 2gx into lx, x square term, quadratic. 2gx into my, xy term, quadratic. Yx is quadratic, y square is quadratic. X square, y square and xy. So all the terms in this equation are quadratics. So this equation is a homogeneous equation. And we have seen that a homogeneous equation in x and y always represents pair of lines. So they represent pair of lines which start from origin with the point of intersection at origin. With point of intersection at origin. This is the first conclusion. So this equation represents a pair of lines with point of intersection at origin. Now the second point is, does this pair of lines pass through these 2 points? If I can prove that this equation gets satisfied by these 2 points A and B, does it prove that this pair of lines are this pair of lines? Yes. Because we have already seen that this represents a pair of lines through origin. Now if you arbitrarily draw any pair of lines, they won't be satisfied by A and B. So if this pair of lines satisfies these points A and B, then this equation has to represent this pair of lines. Now if this point is alpha comma beta is the point of intersection of the curve as well as line. That means alpha comma beta satisfies this equation as well as this equation. That means L alpha plus M beta plus N is equal to 0. This implies L alpha plus M beta is equal to minus N. L alpha plus M beta by minus N is equal to 1. So if you substitute alpha comma beta in this equation, these terms will become equal to 1. And what you're left is A alpha square plus 2H alpha beta plus B beta square plus 2G alpha plus 2F beta plus C, which is equal to 0 because alpha comma beta is also a point on this curve. So the point of intersections of this line and this curve satisfies this equation. It means the equation passes through A and B. So this equation represents a pair of lines through origin, and the pair of lines pass through A and B. Hence, the equation has to be the equation of this pair of lines. So that's the logic of homogenization. I hope you have understood this logic. It's a very interesting logic. 2 sets of pair of lines. If you have 2 sets of pair of lines, that is pair of lines 1, pair of lines 2. So these 2 pair of lines are said to be equally inclined to each other. So 2 sets of pair of lines are equally inclined with each other. So 2 sets of pair of lines are said to be equally inclined to each other if they have the same angle bisectors. If both the pairs have the same angle bisectors. So 2 sets of pair of lines are said to be equally inclined if they have the same set of angle bisectors. So if you are asked to prove that the pair of lines are equally inclined to each other, you find the angle bisectors of the first pair of lines find the angle bisectors of the second pair of lines. If both of them are in the same direction, they don't need to be meeting at the same point. So if the pairs have the same angle bisectors, that is, angle bisectors in the same direction, that means you need to find the angle bisectors of the first pair and the pair of angle bisectors of the second pair. If the quadratic part of both the equations is same, then we say that the lines are equally inclined with each other. Thank you.